All right, let's get right into it. If you've ever stared at a coding interview problem and just felt stuck, like you're trying to climb this impossible mountain, I get it. We've all been there. But what if I told you there's a secret key? A way to see through the complexity? Well, today we're going to crack the code on a huge, and I mean huge category of interview questions, all by using one single powerful concept. So, have you ever noticed this? You're grinding through problem after problem, and they all start to blur together. They feel kind of the same. You start asking yourself, wait, am I solving the same problem again, just with, a different story wrapped around it? It's a really frustrating feeling, for sure. But here's the thing. That feeling, it's actually a clue. And here it is, the big secret. They feel the same because, well, they are the same. The reality is that something like 80% of the questions you'll face are just a few core patterns wearing different costumes. Winning in these interviews isn't about being some kind of genius who invents a new algorithm on the spot. No way. It's about being a detective who's gotten really good at seeing the pattern underneath this disguise. And look, mastering these patterns, it's the absolute fastest way to build real confidence. Because once you start seeing a pattern instead of a random, scary puzzle, the whole dynamic shifts. The interview stops feeling like a test and starts feeling like a place where you can actually showcase what you can do. So, the big question is, how do we spot these patterns? Well, it turns out that so many of them can be unlocked with one master key, and that is hashing. Now, for a second, I want you to stop thinking about hashing as just another data structure. Instead, think of it as a whole problem-solving philosophy, one that's guided by a simple but incredibly powerful rule. This right here, this is the golden rule. You need to burn this into your brain. Seriously. Anytime you're reading a problem and you see key phrases like find something quickly, or check if an item exists, or count how many times something appears, a giant neon sign should light up in your head screaming, hashing. That is your signal. That's the tell. Okay, so talk is cheap, right? Let's actually see this golden rule in action. We're going to walk through 3 absolutely essential patterns that pop up in interviews all the time, and you'll see how they all become almost trivial once you apply this one simple rule. First up, we've got the most fundamental pattern of them all, frequency counting. The problem is dead simple. You're given a bunch of stuff and you just need to count how many times each thing shows up. This is a textbook count frequency problem. The logic here, using hashing, is so intuitive, it's beautiful. You just walk through your list. Every time you see a number, you use that number as a key in your hash map. And the value for that key? That's its count. So you see the number 5? You go to key 5, and you bump its count up by 1. You see another 5? You do it again. It's just that straightforward. And what's amazing is how that clean logic translates into ridiculously clean code. I mean, look at this. You make a hash map. Here, it's an unordered map. You loop through your array, and for every element X, you just tell its counter to go up. That's it. 3 lines. Problem solved, and solved efficiently. All right, let's level up a little bit with our next pattern. This is the two-sum problem, and it's an absolute icon of coding interviews. The goal is to find 2 numbers in an array that add up to some target value. This is a perfect mix of find quickly and check existence. So, without hashing, the brute force way is to check every single pair of numbers. It works, but it's slow. With a hash map, though, the logic is just genius. You only go through the array once. For each number, let's call it X, you ask yourself a really simple question. To hit my target, what's the other number I need? You calculate that need, and then, here's the key, you do an instant lookup in your hash map to see if you've already seen that number before. This little snippet of code right here is the heart and soul of the solution. That one line, that mp.count need, that's where all the magic is happening. It's using the check existence part of our golden rule to do in a split second what would have taken a long, slow search. It is a massive, massive win for performance. Okay, now for a pattern that, at first glance, feels a lot trickier. The question is, can you find a chunk of the array, a subarray, where all the numbers in it add up to 0? This seems tough, right? But it turns out there's a really clever insight that makes it a perfect problem for, you guessed it, hashing. So here's the clever trick. Instead of looking at every single possible subarray, which would take forever, we do something different. We keep a running total as we walk through the array. This is called a prefix sum. And at each step, we store that running total in a hash set. Now, why do we do this? Because, and this is the aha moment, if you ever calculate a running total that you've already seen before, It's a mathematical guarantee that all the numbers between the first time you saw that sum and now must add up to 0. And the code makes this idea so clear. We add the current number to our running sum. Then we just ask our hash set a simple question. Hey, have I seen this sum before? That s.count sum check is our golden rules check existence principle in action again. It takes a really complex sounding problem and boils it down to a simple, super fast lookup. Okay, so by now, hashing probably seems like some kind of a superpower, and in many ways it is. But, and this is important, knowing when not to use a tool is just as crucial as knowing when to use it. Let's talk about some of the common traps so you can avoid them. Let's get really clear on this. Hashing is your absolute go-to when you're dealing with unordered data and you just need speed. But if the problem requires your data to stay in a sorted order, or if it asks for something like, find all the numbers between 10 and 100, well, a hash map is totally the wrong tool for the job. It's just not built for that, and trying to force it will lead you down a very inefficient path. And here are some of the classic mistakes that interviewers see over and over again. The biggest one by far is using a slow, simple array for lookups when a hash map would be instantaneous. Another one is just overthinking it. Sometimes the problem really is just a simple frequency count, and that's it. Knowing these patterns helps you sidestep these common pitfalls when you're under pressure. All right, let's pull all of this together into a winning strategy. It's one thing to know these patterns, but how do you actually apply this thinking in a real live interview? You need a repeatable process, a mental checklist you can run through every single time. Here's your game plan in 3 simple steps. First, always start by explaining the simple, slow, brute force solution. This proves you understand the core problem. Second, you find the bottleneck. Where is it slow? Is it a search? Is it a lookup? That's your target. And 9 times out of 10, the way to optimize it is by applying one of these hashing patterns. And third, for bonus points that will really make you stand out, briefly mention hash collisions. It shows you have a deeper, professional understanding of the tools you're using. So, there you have it. We've talked about the secret to interview problems, we've learned the golden rule, and we've walked through 3 core patterns that can unlock a massive number of questions. This knowledge is officially in your hands now. So, the only real question left is, which one of these patterns are you going to master first?